Good day. It's Michael O'Connell here with the TIBCO Analytics Group, and we're running through today's meetup for November 2019. Just a couple of confidentiality announcements and disclaimers at the front here. So be sure to join your TIBCO Analytics Meetup. There's a lot of opportunities for you here to learn and network. We've now got more than 800 folks who come along to these meetups, and you'll get links to slides, recordings, announcements of new meetups, and so on. So I'm going to kick it off with a little welcome. We're going to jump into this demonstration on liquidity risk, showing the analytics portfolio all the way from data management to data viz. Okay, so let's jump right in. So a few themes in this analysis. Firstly, analytics is really about insights and actions, and not pictures. One of the pioneers of visual analytics, Ben Schneiderman, talks about this in a recent interview, and that's a key theme. You'll see the analytics used to generate insights. In terms of financial services, there's a lot of activity at the moment, accommodating monetary policy, increasing uncertain economic environment. Retreat from global coordination, shift to regulatory supervision, new technologies. So a lot of activity there where risk really matters. Another theme is around analytic time zones. And in terms of strategic, tactical operations and execution, strategic is really on a more of a quarterly or yearly basis, and tactical is weekly or monthly. Operations is your current risk position, and then execution is identifying suspect trades at the moment that they occur. And we're going to touch each one of those strategic time zones, strategic, tactical, operations, and execution time zones. And we're going to see how modeling and simulation plays a role, regulatory and regulations and compliance, governance, operations, and also monitoring and alerting of actual trades. Another theme is that a lot of time is being spent on data prep these days from a data scientist perspective, and how do we minimize, how do we help with that process, and how do we tie it all together? So looking at data management on the top right hand side here, we'll show you our data virtualization technology for virtualizing, federating multiple source systems. Now looking at the data visually in Spotfire lower right, running data science models lower left, and putting those on the event stream in the top left. Now we'll be focused really on the capital markets side of the house here. So oversight, operations, real-time risk control here on the cap markets side, corporate risk, execution, risk management, compliance area. So we'll touch a number of functional areas in the cap markets landscape. And really the challenge around liquidity risk is organizations need to understand and report their liquidity position. And stocks held in multiple positions can't simply be sold or dumped because they might affect the market and the price of the stock. So the stock has to be liquidated over a period. It's the liquidation profile. And there's a lot of factors that affect that. The ratio of shares to outstanding shares, the difference of bid to market price, an impact coefficient that indicates the volatility of the stock or the market. You'll see how that is involved in the model. And that's different for every stock held, and it's also constantly changing during market dynamics and current trading activity. So we'll show you a solution where we bring data in from the trades on a Kafka stream into TIBCO's through TIBCO Streaming into our ComputeDB product. How we federate that data with portfolio and market data in our TIBCO Data Virtualization product. How we set up some rules and parameters in our EBX as metadata, and then how we use TIBCO Data Science to build a model using those rules and parameters, visualize the results of that, and then push the model back into ComputeDB to run on new data that's coming in on the event stream, new trading data. So you'll see that end-to-end solution. Now, there's a number of building blocks in that solution. You'll see our DB pieces plays a central role. Data science plays a central role in building the model. Streaming into ComputeDB plays a role, and then visualizing the results. So our TIBCO Streaming product, just real quick, it allows you to bring data in on an event stream, apply rules and models directly on the event stream, make thresholds on top of those that drive certain actions that can be notifications or stop a certain trade, that kind of a thing. So really math on the event streams. This is a data ops kind of function at the outset, and then a model ops function as we inject a predictive model to run back on the event stream. So both data ops and model ops covered here. The ComputeDB allows you to bring in an event stream in real time, but also view the data, either columnar or row or proximate query for consumption by data science and visual analytics. This is a highly performant distributed in-memory database, 20 to 100x more performant than Spark, for example. Data virtualization, you'll see how we federate multiple data sources, including the trades with the market data and so on, to provide that multiple source system view and a virtual view for the data science and visual analytics products. And then our data management offering, TIBCO EBX, allows you to set up a certain model. In this case, we're setting up metadata for running, modeling the liquidity profile and impact coefficients and so on. So fairly minimal involvement of EBX in this particular case, but in general, this product allows you to model data, match and merge, put security and governance on top of that, workflows for publishing into the model, different hierarchies from different functional areas that you can apply to the model for different stakeholders, and then pushing that out as views for the data science and visual analytics. Now, the data science is a strong product. You'll see that plays a pivotal role in here in predicting the risk of a certain trade. It's a product that has a cloud UX for data prep, machine learning, point and click, lots of operators, but also Python notebook you can drag right onto the canvas, social Slack-like collaboration with all the compute driven down into the cluster or in the database, running distributed at scale on billions of rows of data. And then Spotfire, of course, now real-time enabled. You'll see things like the top graph here, the green line is the days to liquidate estimated by the model, and the blue bars are the cash that needs to be liquidated. And so you'll see even low cash positions might take a number of days to liquidate, depending on how volatile or how fluid that particular or how thinly or thickly traded that stock is. So look, without further ado, let me hand off to Ian to walk you through the demonstration of how the liquidity risk application works, combining these various building blocks. Ian?
Okay, thank you very much, Michael. Okay, just checking that you can see my screen.
Yes, we can.
Okay, thank you. So as Michael mentioned, the first stage of this process is actually going through the streaming product. So in this case, what we're doing is we're taking a simulated stream from Kafka, and we're actually using it to initially just insert the data into the database. The database that we're going to insert into here is actually our ComputeDB database, and we're essentially inserting each individual streams that occurs into the table here. I'll just start this running for later. ComputeDB itself has a UI with it, which is really a web-based UI, which is using the Zeppelin notebook interface. So this is an interface that we can see on top of ComputeDB. So for example, the table that I'm inserting the data into is this trades table, and you can see here that we can actually see the data. We can run various different queries against it. We can visualize the data in different ways. But in this particular case, rather than consuming the data through this notebook interface, we're actually going to combine and federate that data with other information using the DV product. So this is the Studio product inside of DV, and for those that aren't aware, what data virtualization allows you to do is to connect to a number of different data sources. So in this case, we're connecting to the ComputeDB database, and there again is the trades table, and we can see data from that table live. And we're then going to combine and federate that with data, in this case, market data. In this case, we're simulating the market data coming from files, but in reality, this will probably be coming from a web service or a live feed. We're also combining that data with a set of rules that are coming from our EBX product. And in that case, the EBX product is actually publishing the information out using a web service. So we're consuming that web service here inside of DV, which is obviously an XML feed, and we're actually translating the XML into a relational view. And actually, we're caching that data on a periodic interval, just so that we don't keep overloading the EBX system. We're just pulling data every second rather than every single transaction, which is enough real time for us in this particular case. So that information is being combined together. We've got various different rules, and actually inside of the DV itself, we actually have a scripting language very much like PLSQL, and that's being used in combination with SQL to create a set of views, which are, first of all, giving us an indication of the different portfolios or the different positions being held here. First of all, as a breakdown by who's doing the trading, but also what portfolios rather are owning the different stocks, and then we're calculating the liquidity position using these various different functions. And that obviously can create quite a complex data architecture. So if I actually look at the liquidity profile that we're publishing here, you can see that I'm able to see the full lineage of this right back down to the data sources. So here you can see we're combining the transactional data coming into ComputeDB with reference data coming from the market data. You can see there's the rules coming in from the EBX product, and it's all being combined through into various different views and data services we're creating inside of DV until we actually publish this cache view into liquidation profile view, and that's what's published out for querying. So the data here obviously can be maintained in a real-time manner. So as data is changing on the fly, the data that we're actually querying through the DV layer is actually reflected in the queries that we're sending to it. So there's no need to create an intermediate data store here. The queries are actually going against the back-end systems, and we're seeing a live view of the data. So in this case, we're producing a set of views, and we're then visualizing those views in Spotfire. So here's a Spotfire dashboard, and you can see here the graph at the top, as Michael explained earlier. The green line here is actually showing the number of days it will take us to liquidate a various stock that we're holding, and the blue bar is the amount of cash that we're holding in that stock. And here you can see this is a liquidation profile. And so this is being calculated inside of DV and is now being visualized inside of Spotfire. And because of the Spotfire drill down capability here, I can just select a limited number of stock and see exactly what the profile will be for those. We're also through the DV layer calculating the breakdown by position. So we can see here, these are stocks that are being held by individual traders that may be contributing to our liquidity position. And likewise, we have the same for across the different portfolios. And also we can see individual high impact trades. So these are trades that are holding the largest amount of funds in their portfolios. So all this is being calculated on the fly as DV is generating the views across ComputeDB and also the market data. So because this is live, we can see changes in this as they happen. The first thing we can do here is we can actually simulate a new feed of transactions coming into the trading system. So going back to our streaming product here, what I'm going to do is I'm going to now fire in a new set of transactions into the system. So this is going to create new trades into the actual ComputeDB server. So if I go back into the dashboard here and go back to the liquidation profile and update the data, and incidentally, we can feed this data live into Spotfire as well. In this case, I'm just doing this manually to show the effect. Here you can see that the liquidation profile is changing over the time as we reload the data. So the graph is and the visual analytics are responding in real time as the events are coming in here. Of course, the other thing we could do is change the input parameters to the models. So if I actually go to the EBX platform here, in this case, this is a login to the EBX system. And the EBX system in this case, as Michael mentioned earlier, EBX has a capability to handle lots of things like reference data and for you to model data. In this case, we're simply using it for reference information to feed into the models. So this is the information that's actually driving the model calculations. So here we can see for either a market or for an individual stock, we have the rule that we're going to apply in terms of the calculations, and also a sensitivity in terms of the impact coefficient. So let's change this one that's actually causing us a long tail in our visuals, this SVT stock, and let's change the impact coefficient on that. And as I mentioned earlier, that data is being pulled through a web service into DV and being cached. And so if I now go back into the dashboard and now reflect and update the data, what we should see here is that will now have an effect on the calculations of the liquidity profile. So instantly you can see the number of days to liquidate the stock has gone down by instantly changing that parameter. So here everything is real time and we can see the effects of what's happening. So using this, we were able to see exactly what's going on in the liquidity situation. But it would be nice, rather than to look after the event, to actually look as things are happening. So in case as transactions are actually occurring, whether we can predict whether the transaction that's occurring could have a negative impact on our liquidity position. So going back to the DV, what I've done here is I've created an additional view called high risk trades. And you can see here that we've added to the trading data an additional column which indicates for each trade whether there's a high or low risk from liquidity point of view. The problem is that this calculation that we're doing at the point at the time inside of DV is actually using information that's not available in the trade itself. It's using information that we're calculating from the other different views. So in terms of the actual stream base where we actually are receiving the trade, we can't actually do this calculation. So what it'd be nice to do is see whether we can actually instead create a predictive model using the various different fields that we do have at the point of trade. So that's exactly what we've done here. I'm now going to use the data science platform. And inside of the data science platform, we've actually built a predictive model. So I'm starting off with exactly the same data that you've just seen, the same table with the indicator of high and low risk as our dependent variable. We're doing the usual process of splitting this into a training set and a holdout set. And because this is just a binary classification problem, I'm using different algorithms to assess that. So in this case, there's regression, a Bayesian, and a neural network. And we've trained the models. And the important thing here is, as Michael mentioned earlier, this workflow that we're executing is pushing down into our Spark-based analytics system. So all the computation is being done against a cluster. So this can be done against very, very large sets of data and can be done at speed because of the parallelism that we're able to achieve from a large cluster back-ending this. And we can see here that the goodness of fit, that each of the models actually scored very well, but in this case, the logistic regression model was particularly good, almost, well, actually 100% accurate against the training set that we provided. That's good because also an LR model is actually very, very quick to compute at runtime. So what we're able to do now is export that model. Using this node here, we're able to generate model details in a format called PML, which is a standard format for specifying the content and models. So we can now take this model and we can feed it back into our data stream in Streambase. So within Streambase here, we have a different workflow. And in this case, the workflow is taking the same workflow as before, but in this case, as the trading information is coming in, we're feeding into the model that we've just generated. So this node here is taking the same PML file that we just saw and generated out of the data science tool, and we're using it to calculate an additional column. And actually what it's going to do here is it's actually going to insert that additional high and low field into the table based upon the model predictions. And notice it's just using columns that are available in the trade. So if I actually kick this stream off now and go back into Spotfire, we've created an additional tab here, which is actually now showing the trades as they're coming into the system. And you can see here, this is the same trading data as before, but we're now actually calculating on the fly using this predictive model an indication of whether the trade is a risky one from a point of view of liquidity, which is flagged as high and low. And if we can't assess it, because the model can't predict it currently, then it's flagged as blue. And again, if I refresh the data, you'll see this position is changing in real time as trades are coming in. So obviously one thing we can do here is to eliminate these blue areas. Is we could take this larger data set and rebuild the model, compare it to what we're getting now, and from model ops perspective, feed that back into Streambase. So you've seen here we've been able to combine together several tools inside of the TIBCO Analytics suite, to connect to a live stream, to process it at speed using a analytics database, to federate that data with other information, to calculate the liquidity model on the fly, to visualize it, and to produce a predictive model which can then be fed back into a live stream to classify individual transactions. Okay, Michael, back over to you.
Okay, terrific. Let me share my screen. So thanks, Ian, for that great demo. And we're going to now unpack the demo and have some comments from you, Ian, as we go through each piece. Sure. So starting with the ComputeDB notebook interface, can you just talk about the data coming into ComputeDB from TIBCO Streaming and how we can configure that and through the notebook interface?
Yeah, so ComputeDB is essentially really the marriage of two different technologies. The front end of it is Spark based. So essentially you have all the capabilities as you do in Spark. So the ability to process data using SQL or Scala or Python or R. And you can actually create tables in ComputeDB itself, which are either held internally inside of ComputeDB in its other side of the technology, which is an in-memory database, or can point to external files. And using the Apache Zeppelin notebook interface, you can run various different queries against that, using any one of those languages. And Zeppelin is a capability that allows you to run multiple different languages in the same notebook, and they can all be run inside of the ComputeDB platform. Probably the big, sorry, go ahead.
Go ahead, Ian. No, I was just going to say the big thing here is that, in terms of data coming in is one thing, but also pushing the model back into the ComputeDB interface. And the fact that it's highly performant, can shave a few milliseconds off the whole process compared to, say, a Spark interface, which allows the trader to get out in front of the market in a legal manner. That gets that little bit extra, performance can really make a difference in this particular situation where you're trying to, sell off a stock with the market conditions, moving so quickly.
Absolutely, yeah. Time is of the essence here. So having the fastest technology available to you to do this is key. And you can see here that we're able to push models back in and execute them at very, very high speed. And part of the reason that we're able to do that is the back end of ComputeDB is an in-memory database. And also we can orientate the tables to be row-based or column-based that suits the data and the queries that we're running against it. So we're able to get very, very high levels of performance, both from an analytics point of view, but also from a transactional point of view using that technology. Exactly.
So I just want to point that out. So Ian, there's a few comments on what TIBCO Data Virtualization brings to the table here.
Yeah, so data virtualization, as I mentioned earlier, is a way that we can actually combine data together from very disparate and different data sources. So the product actually comes with over 100 different adapters now. So it isn't just combining together, relational technologies. We can be pulling data from web services, from files, from social media, from NoSQL sources, from web applications. And essentially, in all cases, what we try to do is we try to make those data sources look like they are SQL-based, and so that we can then combine them together. In this case, showing how we can combine those together visually using a graphical builder that we have inside of here. And actually what behind the scenes it's generating is actually a SQL statement that's run by our optimizer. The optimizer is kind of like a federated optimizer, which actually is looking at minimizing the amount of data that we move around to solve a particular problem. So it will try and do things like push down functions and queries and joins to the backend systems so that the data is processed in the source system and we only move out the data that's required. We can also combine that with things like caching to temporarily hold the data. And also we have things like data shipping where we can move data temporarily from one database to another, and also massively parallel capabilities in here as well, so that we can actually combine data at speed, leaving the data in the storage systems where it's best managed, rather than having to move it out into a new data store, because obviously that has associated cost and development time associated with it. So DB allows you to do integration very, very quickly. It's very agile. It allows you to then see that data either as a SQL database that can be queried using standard ANSI SQL from a tool like Spotfire, or we can publish those same services out as web services. So it can also form part of a data services layer. And we're also capable of doing things like security against that data. So as it's passing through the DB layer, we can do things like row level filtering of the data, column level masking and obfuscation. So it can also, as well as handling federation, handle very complex security across a wide variety of different data sources.
Terrific. So, and basically the PL SQL layer, part of it is very flexible. I think you mentioned some of that. So let's get into what the EBX brings to the table this time.
Yeah, so EBX is actually a major piece of technology. In this case, we weren't really using just a very, very small subset of it in terms of actually creating some reference data. In this case, the reference data is being held in EBX. What EBX allows you to do is to model data from different perspectives, either from a master data management perspective, from a reference data perspective, and you can then tie up exactly where that data resides, either inside of EBX or inside of other systems. It allows you to rationalize that data, obviously look for duplicate meanings, but also duplicate data, and obviously to feed that back into the systems that are holding that information. We can also put against that data security rules, defining who can see what. And so there's a great deal of ability to manage and govern the data that's held in a number of different systems. And also that information.
In this case, we're just really managing the data for the model though, right?
In this case, yes, we're using a very, very, say, small part of this, which is just simply, in this case, to provide the rules that are feeding into that model.
Right,
right. And in this case, we're consuming that information that you're seeing on the screen here as a web service into DV. And the reason why we're doing that is the minute that you make a change inside of EBX, that information is immediately seen inside of DV. So it helps us to maintain it and capture that real-time nature of the data.
Perfect. So now as we go across into the data science product, I think one of the key aspects here is we're building a model only with parameters that are available at the point of trade, so that we can publish back, into that real-time system, right? Yeah,
that's the key point here. Although, in DV we did a calculation, we can't actually make that calculation at the point of trade because the parameters that we're using are not available. So by using more predictive techniques and using things like neural networks and other statistical methods, then we can try and see that if we can make a prediction based upon parameters that are only available at the time. Right. So going through the training process and doing a binary classification here, we could see we could actually get quite an accurate model just based upon those parameters, and we were able to test that inside of the tool. And you can see that's all built just as a workflow, drag and drop here. This is a low code situation, although the product does allow you to drop down into code if you need to. And then the last stage here, as you're highlighting, is we have the ability to then export that in a format, in this case PMML, which is a standard modeling format that we can then take from ModelOps perspective and feed directly back into the streaming, TIBCO streaming that we saw earlier.
Exactly. So basically, here's where we stick in the PML inside of the streaming workflow so that new trades coming in can have a prediction about their risk associated with them.
Yep, exactly that. And so we've now derived that model and gone through the complexity of doing the calculations to build it using the Team Studio tool. And the runtime is just an execution of that model as part of the streaming process.
Right, right. And so now then we can add this extra column to the Spotfire analysis showing the predicted risk of each trade. And as Ian showed you, you can see how, as you click around, as the trades change, you get the updated predictions, and you can take an action on that. So I think that kind of wraps up the unpacking of the demonstration, Ian, and really what you've shown is how to federate those data real time into the Spotfire and data science model, manage the parameters from liquidity rules from EBX, publish that model back to operate on new trading events, add that extra column for predicting the risk of the trade, and invoke an action on top of that. So I think that's kind of the end-to-end story. Any other comments, Ian, before we transfer to Helene?
No, Michael, I think that's really a good summary of what we tried to do here. I mean, the important thing here is, this is combining different technologies together to do this. And obviously the different technologies we use are providing a different part of the picture, and, the extent to which we use them will depend upon the problem we're solving. But,
Right.
These tools are exist in their own right, but have the ability to be easily combined together to form a whole picture.
Yeah, and we're big in the financial services industry and risk in general. So, for example, some of the rules that you can add into the streaming infrastructure in this TIBCO streaming product can be things that can, I mentioned getting a little bit of an advantage there with respect to legal front running, but also putting in rules there to track, potential spoofing or other ways that other traders try to either manipulate the market or this is a delicate situation trying to sell shares when you've got positions more than you want to have, and the market, has its own behavior. It's a delicate situation, and you can have a whole bunch of other rules inside of our ComputeDB and streaming products that allow you to manage other sorts of high-frequency trading, aspects of a trader's life. So yeah, as Ian mentioned, individual functionality of each of the components can be brought to bear on this problem or other similar problems, but the combination of the products, really gives you that control over individual pieces of the puzzle as well as the overall trading and risk management. So with that, Helene, I'm going to hand off to you to wrap it up.
Yes, so the TIBCO community update, quick run through of some new relevant content for you to help you make the most out of the TIBCO software that you use. So the TIBCO data science team is quite active with producing things for you here. One of the things that we've been doing recently a lot is writing blogs. So this is a new functionality of the TIBCO community that we showed last time. We've produced 19 blogs since then, so a lot of great content there for you to use, tips and tricks, event coverage from interesting customer presentations where we wanted to highlight some of the features or use cases, some of the templates that are available and extensions from the products with detailed description of the use cases. So a lot of good information, and I think this is really a nice place for you to check, once in a week or so to see what new information is out that will help you keep an eye on new content on the TIBCO community, because it's a little bit hard if you're just looking for specific wiki pages, although search in any search engine or the community itself should work well as well. actually, what I forgot to mention is that for new users on the TIBCO community, you will be asked to register. Once you're registered, you can interact with the community. So you'll be able to post questions, add comments, create your own wiki pages, and do anything you'd like to do. So we would encourage you to register and visit the community.tibco.com frequently. So we've talked about the blogs. The other thing I wanted to show is some new content on the wiki. And it's actually orientation pages. So we have created, we've actually showed in the past the orientation pages for Spotfire, but we actually have 6 of those now for different products. And the ones that I wanted to point out today, because we're talking about TIBCO Data Science, are the TIBCO Data Science orientation pages. So just as an example here, TIBCO Data Science Team Studio, our big data solution. This is a page where you can just scroll through and find information for different personas, how to access the software, some enablement information, and some additional resources. So an easy starting point to get to all the content relevant to TIBCO Data Science for you. The other thing I wanted to show you is 2 updates on Exchange items. So the Exchange is where we post the templates or accelerators or extensions of our products that help you do even more. Examples that we actually presented last TIBCO Analytics Meetup is AutoML, so Auto Machine Learning extension for TIBCO Data Science Team Studio. AutoML is really the automation and optimization of some of the common steps to train a machine learning model. So this is very useful. And we've just released a new version of that with a few additional functionalities. There's an explainability component to it, also using Spotfire. There is an auto-generated scoring workflow, and there's also some new feature engineering applied to it. So please take a look. Let me just show you what it looks like on the Exchange itself, if you haven't used the Exchange before. So when you click on an Exchange item, it will always look like this, with a few tabs underneath. So this is just a summary of what the Exchange item is, the information on the release. So this is where you can see that the new release is out. And then reference info actually links to the community wiki page that has all the detailed information about the component or the templates and how to use it, how to install it, etc. So that's a new item on the Community Exchange. The other new item, or the updated item that I wanted to point out today, is the data function for TIBCO Data Science Team Studio. So that is an update again. This is a way to call workflows from Spotfire or from TIBCO Data Science Team Studio from Spotfire. So you can be in Spotfire and run a workflow in the TIBCO Data Science software in the background. So it's just a further extension of the various data science engines that Spotfire can work with. So those are the Exchange items. The other thing I wanted to mention is the TIBCO Analytics forum page. So let me just search for that. The TIBCO Analytics forum was a big event in Houston, end of October. With lots of customers. It was analytics focused, obviously, a bit wider for industry. It used to be just energy, but we've expanded this to include broader industries. And we had lots of positive feedback on the event and lots of questions, of course, to share some of the content. So I think you will find a lot of that here with pictures and descriptions of the presentations. And for those customers that are willing to or were able to share their presentations, we've added PDFs, for example, here for ConocoPhillips, to the community page as well. So take a look, enjoy. There have been blogs written up on all of this as well. I think you'll see sort of coverage of this content for a while because it was a very rich event content-wise. So hopefully you'll enjoy that. And the last thing I wanted to show, I'm actually going to just exit the full screen view for that. The last thing I wanted to show, you can also get to this from the TIBCO community, but I just wanted to point out there's a Dr. Spotfire session coming up on December 3rd that is all about scaling Spotfire and the Spotfire server. So we hope that many of you can join. This is an increasingly popular session. And if you have any questions about it, just contact us again via the community with hashtag Dr. Spotfire. You can ask any questions that you would like. And then that actually brings me to the end of this TIBCO Analytics Meetup. I think we've answered all of the questions about the liquidity risk demo in the discussion between Ian and Michael. Thanks for that demo, Ian and Michael. Thanks everyone for attending. And if you've signed up for the TIBCO Analytics Meetup group, you'll be notified as soon as the next one is being scheduled. So see you all next time. Thank you.